Hello, these are solutions to checkpoint module 2. Here we were asked to explain whether this is an equation of a function or represents a function. We solve for y, we take square roots. Every time we take square roots, we have to write plus or minus. And it turns out that I have to show for one point that that's sufficient. When x is 0, the square root of 25 is 5, but I get two different y values. So for one x, I get two different y values, which is not a function. Here we normally simplify this function, but let's say we don't. So when we plug in 5, we have 8 in absolute value, which is 8. 8 over 8 is 1. When we plug in negative 5, we have at the top the absolute value of negative 2, which is 2, but the denominator is negative 2. 2 over negative 2 is negative 1. Here all we have to do is just replace x with negative 9 minus x, negative 9 minus x plus 3, and the same negative 9 minus x plus 3. We simplify the numerator as negative x and minus 6, and the denominator is also negative x minus 6. We can pull out a negative in front of the fraction line and change these into x plus 6, and we can leave it as is. There are ways of simplification this, but that's fine. These were all read from the graph, the domain, the range. I think it was the obviously the x-intercept, the y-intercept, and a function value. Same thing here. Domain, range from the book. In section 2.2, these are the previous ones. In section 2.2, the function was never increasing. Look at the graph, please. It was decreasing between, all these are open intervals, negative 4 to 2, constant between negative infinity and negative 4, union 2 to infinity. We read all these values from the x-axis only. Here we're asked to show whether it's symmetric in any way, shape, or form. If we replace x by negative x, there is no change. So it is symmetric with respect to the y-axis. When we replace y by negative y, there is again no change, so it's symmetric with respect to the x-axis as well, which is not a function. As we know, symmetric with respect to the x-axis is not a function. And then we replace both at the same time. Again, there is no change, so we get symmetric with respect to the origin. All these were read from the graph, the main range, x-intercepts, y-intercept, the function was increasing on these intervals, decreasing on these intervals. The function is less than or equal to 0 when the function is under the x-axis. It was under the x-axis between for x between negative infinity and negative 4 union 4 infinity. X equals negative 2 and x equals 3. We were given, I think, a y value. I'm not sure. At x equals negative 2, oh yeah, the relative max. Okay, so at negative 2 there is a relative max of 4, and at 3 there is a relative max of 2. F of negative 2 was 4. F of x is 0 is the same thing that we obtained here in part C. The x equals negative 4 and 4, and the function is not symmetric, with respect to the y-axis, and is not symmetric with respect to the origin. Then we are asked to graph a piecewise defined function. And the way I present this, which I think it's the easiest way to understand, is I'm changing this inequality into an interval, which is negative infinity, negative 3, and this one into negative 3 to infinity. So the first piece between negative infinity and negative 3 is used here, which is x plus 2. Between negative 3 and infinity is used x minus 2, the second branch. Now, see these symbols, the parenthesis and the bracket, they're right here touching right under negative 3. For the left side, I plugged in negative 4 plus 2. I plugged in negative 3 and I got negative 1. You could say you're not allowed to plug in negative 3. True, I'm not, but this will be an open point. So on the other side, negative 3 minus 2 is negative 5. I plugged in 0, of course, and 2, of course, because these are x and y intercepts. We should always look for those if possible. So here they are. The left side is a graph that ends here. It cannot be extended to the other side. If you do extend it, this will not be a function anymore. By the vertical line test, will not be a function. Careful. This branch is only between negative infinity and negative 3. And this branch is only between negative 3 and infinity. So I plot the points, and I found that the domain and range, of course, the domain was determined from the very beginning, from here, from these two. And the range is also all real numbers. Here we're reading from a graph. F of 3.5 is 1.15, which is, and 3.5 ounce letter will cost this to mail out. Here we were given 2 points. I found the slope, and I plugged it in. Y minus y1 equals the slope times x minus x1. Why? Because I was not given 0 comma b to write y equals mx plus b. So after I plugged it in, I plugged in this point. It was easier for me, but you can plug in this point, you still get the same thing. Graphing a vertical line, graphing a horizontal line. So when we only have x, it's position. When we only have y, it's altitude. Okay, here we're asked to graph using x and y intercepts. When x is 0, I cover it. I move negative 20 to the other side. Negative 5, y equals 20 means y equals negative 4. When y is 0, I cover it. I move 20, and I have 20 over 6. But 20 over 6 is 10/3. I plot these points right here, 0, negative 4, and a little bit more than 3. Connect and extend the line. Same thing here, we were determining the slope, and I found the equation in the same way we found it on the previous page. Always when you determine the slope, and this is very important for tests, when you determine the slope and we have measurement units for x and y, if you do not write the measurement unit for the slope, you cannot get full credit. So please remember, if it's abstract, then you don't have to write anything, right? But if it's not abstract and we have measurement units for x and y, it's always the y measurement unit over the measurement unit for x. Section 2.4, the last section for this test, we were asked to determine the equation of the line perpendicular to this one. I have the slope. I know that 2 lines are perpendicular if the product of the slopes is negative 1. So when I multiply these two, I get negative 1. So basically, m2 is negative 3. So the point again, y minus y1, the slope, x minus x1. I put negative 4, I put 2, and I put negative 3. Combine like terms, distribute, move the term, add 2 to both sides, and get this. The same thing here, but parallel. So I have to find the slope here. In order to find the slope, I have to solve for y. So I moved negative 3x, I moved 3x to the other side, and I divided by negative 2 term by term. In order to determine the slope, if the slope of this line is 3/2, the slope of the other line has to be 3/2 as well, because they are parallel. So then I wrote y minus 3 equals 3/2, x minus the point was, one more time, negative 1, 3. Negative 1, 3, and 3/2. I distributed and also added 3. I need the least common denominator, which is 2. I need to multiply the top by 2. 2 times 3 is 6, plus 3 is 9, 9/2. Here we were asked to find the average rate of change. So I have to plug in 9 and get 3. I have to plug in 16, I get 4. And it's the slope, 4 minus 3 over 16 minus 9. 4 minus 3 over 16 minus 9. The top is 1, the other is 7. That's the rate of change. And here we were asked to determine the same thing. Yes. So I had to plug in and find y1 and y2. So it's y2 minus y1 over x2 minus x1. And I got this. Remember, we have to write a measurement unit because that is rate of change, and it's the measurement unit for y over the measurement unit for x, always. Thank you. I hope this helps.